Welcome to the Lava Academy podcast, your monthly dive into the world of volcanoes, lava, and the forces that shape our planet. We are a team of lava enthusiasts based in Reykjavik, Iceland, part of the crew behind Lava Show, the world's first live lava show where we remelt real lava and pour it out in front of a live audience. But this podcast is where we go deeper into the science, the stories, and the people behind the eruptions. And I am your host, Iain MacKinnon. I am a former primary school teacher from Scotland, now playing with lava for a living, lucky me. And I'm joined once again by my co-host, Ragnhildur Ágústsdóttir.
Woo!
Yay! There we go. So, here we are again.
Yes.
With another fun interview this time.
Yeah, I think this is an intriguing one.
It certainly is. Yeah, I'm not going to spoil too much for you here, but it's something I said repeatedly throughout, so I might as well say it in the intro as well. I didn't know a thing about any of this until we recorded this podcast. So this was all kind of new ground for me.
Yeah, and I think a lot of our listeners might find this quite interesting.
Yeah. So what are we going to find interesting? Well, it's going to be this interview that's coming up now. So, welcome back. We have got our special guest with us now, and our special guest today is Ann-Sophie Bader. I was trying to think of how to actually introduce you, and the best I can come up with is that you are an adventurer? ? Could you go further?
I think that is actually a very good description, you could say. So my name is Ann-Sophie. I am from Germany, and I have moved to Iceland 5 years ago and had very different plans, actually. My plan was to actually work in business, but very quickly I realized that was not the path to go. So I worked in the outdoor industry for the past 5 years. And sort of along the way, I managed to get a job in Antarctica. So I work there seasonally.
Wow. Yeah. So let's talk a little bit about how, first of all, how in the world do you land yourself a job in Antarctica? And why?
So when I started working in Iceland for the first time, I actually worked as a glacier guide. And just completely fell in love with working on ice, you could say. I really love being outdoors in the cold, in snow, and all that adventurous stuff for sure. And sort of along that way, I came up with the idea to work in Antarctica. That sort of became my dream destination. But I kind of always thought, okay, this is not just one trip I want to take. This is somewhere where I want to spend a lot of time. And then came up with the idea, hey, what if I just apply for a job in Antarctica? Not knowing anything about the place, I very quickly realized that was not such an easy endeavor. It is actually quite difficult to land a job in Antarctica.
I mean, what kind of jobs are there?
I would imagine the opportunities there are quite limited.
They are quite limited. So there's sort of 3 main things you can do. So the first thing is a lot of science is done there. So a lot of countries have research stations that they mostly just hire people from their own countries, of course. And then the other 2 main jobs that you can do there are in tourism. So one would be working on expedition ships, and then the other one would be working on remote camps like I do now. So the company that I work with is a tourism camp that is quite remote, very far away from the ocean as well. We fly in, and there I work as a guest liaison. So I'm responsible to accompany the people that decide to be
visit
in Antarctica. Yeah, exactly.
That's crazy.
So I would assume maybe like not the usual traveler.
For sure. No, these people are very adventurous, for sure. Many of them are extreme athletes as well, mountaineers.
Okay.
Yeah.
Interesting.
Quite fascinating.
And so you just dug up this information on the internet? Like, hey, maybe I could do this and
Exactly.
just simply apply it?
I did, yeah. So actually, the first season I worked in Antarctica, it took me around 2 to 3 years to actually land a job. And the first job I got was literally cleaning toilets, showers, and setting up tents. So yeah,
So the entry point, you were basically like, if I want to do this, I gotta take whatever.
exactly.
Yeah.
I was like,
Available.
I am willing to do whatever it takes to
Wow.
go down there.
Well done.
Yeah.
And then you've moved up the world and become a tourist liaison? No, what did-
Guest liaison.
guest.
Yeah. Now I'm allowed
Guest.
to speak to guests.
Yes.
Wow. So, I mean, today, obviously, we're talking about sort of, all things volcanic as usual. And I've got to confess that I didn't ever really think of Antarctica as being a particularly volcanic place.
Yeah.
In fact, it was kind of off my radar for basically anything to do with volcanoes, even, plate tectonics and stuff like that. I just kind of ignored this gigantic chunk of rock on the bottom of the planet. But apparently it is actually much more volcanic than I certainly had realized.
If I can chime in,
Yeah,
I
go
mean,
ahead.
we also had a previous episode where we had Sævar Helgi Bragason come in talking about volcanoes and eruptions in space.
In space, yeah.
And I mean, that is also like, I mean, I know that Antarctica is on Earth,
Yeah.
but still somehow becomes something that you don't really think about too
Well,
much.
funnily enough, when I was prepping for this and I was kind of figuring out what we were going to be talking about and asking, I actually felt very much the same as when I was prepping for that episode.
Yeah.
Because honestly, that whole I know now there are volcanoes there, but really my understanding of anything that's going on there is so incredibly limited that it might as well be in space.
Yeah, yeah.
And I think that's probably true of most people. Actually, I don't think people tend to associate Antarctica with volcanoes anyway. So
But you think about ice and that's it.
Yeah.
Yeah, exactly.
So,
Yeah.
how volcanic is it then?
I think the correct answer to that is 50-50, actually.
Okay.
One half is very volcanically active. However, the other half is entirely not. So we have the West Antarctic Rift System on the continent, which is, as the name says, in the West Antarctic part. However, in East Antarctica, there is no volcanic activity whatever. So yeah, it is sort of 50-50, but the West Antarctic Rift System is certainly one of the biggest volcanic system we can find on Earth. And that includes 138 volcanoes. So that is quite a
Now,
lot.
We're not talking about the plate boundary itself.
Correct.
This
yeah.
is splits that are happening inside of that.
Correct, yeah. So what is very different in Antarctica to the volcanic systems that we can usually see, so in Iceland we have 2 tectonic plates drifting apart, or in the Pacific Rim of Fire we can see that, there is one plate moving under the other one, whereas in Antarctica we have this rift system on one tectonic plate. So the movement of the tectonic plate is not the reason. The main reason is that the ground is actually quite fragile. It is very unstable.
Okay.
So there we have a release of pressure, and this is how the volcanic system forms there.
So just a kind of rough overview then, like how much volcanic activity is there, or rather I should rephrase that, how many volcanoes are there, do we know?
Or systems.
Yeah, so there are actually 138 volcanoes that have been found. Interestingly enough, in 2017, they discovered 91 of those. So there is actually...
Whoa!
Yes.
In 2017
Yes.
alone,
Mm-hmm.
they found 91 volcanoes.
Correct, yeah.
They're just like lying under the sofa cushions. They're like, oh, here's another one.
Sort of, yeah. So most of them are completely covered by ice. So you don't see the very typical volcanic cone. And they have been discovered by 3 researchers from the University of Edinburgh. And
Scotland! Freedom! Sorry.
Freedom!
yeah. Yeah,
Good old
it's
Scotland.
actually led by an undergrad student, which I also thought was really interesting. So he
Wow.
actually discovered with a lot of like satellite imagery. That's one of the methods that he used. He found that there's a lot of volcanoes hidden under the ice that we had no idea about, which I think is super interesting because that, of course, makes you wonder, what else do we not know?
Yeah, I mean,
What else is hidden under the ice?
Exactly.
They found 91 in 1 year alone. I mean, as they develop the techniques, you
don't
would
you
imagine
agree?
they're probably going to find it. I mean, the chances that that's it are quite slim, I would
Slim,
imagine.
right? Yeah.
But I will also say, I mean, I feel like it's been sort of a recurring theme now in our podcast, how satellites are being used for volcanic research and anything geological. So maybe this is just relatively new technology that has been adapted to be used in this way, because like we've been using them for decades, of course, for other purposes. But there now we have like the focus being shifted to actually researching areas that may have been overlooked, perhaps.
Yes.
Like
I
Antarctica.
believe so, yeah.
Okay, so how, like, given that 91 were found in 2017, like, are there any speculation that there's still a lot left to be uncovered, or do experts think that this is it, that the volcanoes that are there have been found and discovered?
So I think that depends, of course, on the researcher that you're asking, for sure. But I think the main thing that we want to point out here is how difficult research is in Antarctica. If you just look at the fact that how thick the ice is, it can be up to more than 4 kilometers thick.
Whoa.
So that is a massive amount of ice that we have to penetrate with radar systems, for instance, or with magnetic measuring systems as well. So there is no 3D map or anything like that of the continent. There's a lot of uncertainty in a lot of areas in that research. So I think it is fair to say there is a very good chance there's a lot we don't know.
Yeah, because when we were talking to Christine Jónsdóttir, she was talking about the challenges, even here in Iceland, of trying to, figure out what's going on under the ice caps, under like, Vatnajökull or whatever. And that's not even close to the sheer thickness of ice that you're dealing with.
And again, like
Antarctica.
C mentioned, if you want to, for instance, measure any seismic activity, the measurement tools need to be on bedrock. And I mean, I guess if there's
You're
scars...
drilling down through 4 kilometers of ice to get to rock.
If there's scars in Vatnajökull glacier, they must be almost impossible to find in vast areas of Antarctica.
Yeah, especially because Antarctica is so large. Yesterday, when I was preparing a little bit for this, I actually Googled how much bigger is Antarctica than Iceland.
Ooh,
and the answer is 136 times bigger.
Yikes.
Yep.
Wow.
Okay,
So,
that's pretty big.
Just, the sheer remoteness of it, and also how dangerous it can be with crevasses hidden below the snow, and just the temperatures, and, just getting to these places to even put the radar on it or put magnetic systems on it. It's very expensive as well, of course, because of that. So research is quite limited in comparison to other places. Yeah.
So of these different volcanic systems that they have identified, how much of that is actually, volcanically active as opposed to?
So 2 volcanic systems, 2 volcanoes are considered to be active in Antarctica. One is called Deception Island, which is an island just off the Antarctic Peninsula.
Deception Island.
Yeah, they tend to have quite dramatic names. There's one also that's dormant. It's called Mount Terra. So it's a lot of very dramatic names in
They're
Antarctica.
good at marketing down there.
I know. Yeah, so Deception Island had the last eruption in 1970. So this is actually a caldera that is filled with water, and it has a geothermal beach, which is also very interesting. So that is one of the places that tourists visit quite a lot with these expedition ships.
Have you been there?
No, unfortunately
Okay.
not. Oh, it's such a dream. I would love to go there. It's so interesting.
Next time, maybe.
Yeah. I mean, I would have to go there on a ship. I don't do that so far, but life is long.
Yes.
So. But yeah, the other one is Mount Erebus, which is a very special volcano in a lot of different kind of points. But the main thing is that it's currently erupting. It's been erupting since the 70s, actually, since 1972. And it has an active lava lake. So you can always see red liquid lava inside that volcanic cone.
Okay, so I'm going to kind of like dance around here a little bit. So you talked about Deception Island. And just before you came in, because I hadn't really kind of done an awful lot of research on this either when I was doing this preparation. My preparation was slightly sketchy for this one. But you were talking about that shape of Deception Island. And it really is quite a beautiful kind of horseshoe shape. It's really very clear. And it reminds me a lot of these kind of atolls and things that you see out in the South Pacific or whatever.
Correct, yeah.
But that, like you said, that's the caldera. And from what I found out, this caldera was formed in quite a significant eruption.
That is correct, yeah.
So do you have any kind of information on that for us?
I don't think there's so much information that exists about it, to be honest. So we know that happened about 10,000 years ago. This was when this caldera was formed. And it has a radius of roughly 15 kilometers. So it is really massive. It is really massive.
According to the stuff that I was looking up here, the amount of material that was ejected by that explosion that created that caldera was between 30 and 60 cubic kilometers. Now, to put this in context, Eyjafjallajökull, the famous 2010 eruption here in Iceland that shut down all the airports in Europe, that only erupted about 0.16 cubic kilometers. So 30 to 60 cubic kilometers of material would put it at a volcanic explosivity index number of 5, which is the same as Krakatoa. Or Mount St. Helens, if you want to look at it that way. So it's in that kind of that range.
It's up there.
And that must have been one heck of a bang.
Yeah.
Yes. And I mean, for anyone in probably the southern hemisphere, and maybe even broader than that, any human or animal that would have been alive at that time would probably had some kind of a notion.
Some awareness of it at least.
And I mean, if there was anyone walking for instance, the South America continent at the time, there should have been some consequences after this one. As
a whole bunch of very surprised chin-strap penguins.
For sure. I mean, it must have been difficult for.
But that was a subsea eruption.
That's correct. Yeah.
And we just actually in the last podcast that we recorded, we were talking about Surtsey. And so again, quite strong parallels between what's going on, or what had been going on in Antarctica, and what's going on here in Iceland.
Do you remember the Tonga eruption that happened some years ago? That happened sort of just below the surface of the ocean. It was underwater, but close enough to the surface to create this massive ash cloud and explosivity. And this sounds a lot like it may
does
have
sound
been in a
an
similar
awful
way.
lot like that. I can just it's kind of terrifying. You're
It
thinking
is.
about what it might be like, in the proximity to that.
Maybe that's the reason for the name, Deception Island. Looks innocent.
What is the reason
I
for the
think
name?
the reason is actually that the people that have been going past it with boats, like the explorers in the old times,
Yeah.
you could say, they thought it just looked like an island. But there is actually one very small entrance, you could say, to drive into the caldera, to sail into there.
Mhm.
And this was sort of the deception. So that's when they found out it was actually not an island, but it was a
Yeah, it's
caldera.
basically a giant harbour.
Yeah, exactly. Yeah.
Okay, so the other one you mentioned, the one that is arguably the most active, is Mount Erebus.
hmm
And again, I knew basically nothing about Mount Erebus until very recently.
Yeah.
You talked about the lava lake.
hmm
That is unusual, is it not?
Very unusual. Quite.
Yeah.
Yeah.
In what way?
It's just that we cannot really see that in a lot of places on Earth. I believe there's just 6 or 7 other volcanoes where we can see something like that. And it's also, let's say, a quite fragile system, because one explosive eruption could, of course, stop that from happening, stop the process from
Right.
happening. Yeah.
So if it's that long-lived, if that lava lake has been kind of kicking around up there since the 70s, why is it still kicking around? Like, what is it that's keeping it that way, as opposed to, I mean, we've had, lava pools forming in recent eruptions here in Iceland, but they haven't hung around. So what's the difference there?
Yeah, so first of all, with that concept, there's a lot of question marks still. So there's also no 3D model or something like that of it. So there's a lot of question marks as to how exactly it works. But the theory is sort of that the hot magma will rise to the surface, and the one that has cooled down a little bit, it will sink. So it sort of cycles around like water in a cooking pot, you could
Yeah, it's
say.
like convection currents. Yeah.
Exactly, yeah. And then there's also they call it a faulty vent for the eruption gases that come out. So that sort of gives like little pumps of gases that just come out at a very regular rhythm. And this is
I'm a bit like that.
It keeps sort of stirring.
yeah.
Sorry.
Well, okay, back to the lava lake. So these pumps, regular pumps, they are the one that sort of keep the lake alive.
Yeah, and also
And the circulation essentially alive.
Yeah, exactly. And then also what is pretty interesting about that is that, of course, because it comes so regularly, there is not one bigger eruption. So it is less explosive because there is...
Okay.
Yeah. So it
Interesting.
regulates itself, you could say.
Yeah.
Yeah.
So if it weren't doing that, you would get the pressure build up and eventually kaboom, off we go again.
Exactly, yeah.
But the fact that it's being able to relieve that pressure, like my good self, stops an even more unpleasant eruption from happening.
Exactly.
Shall we say?
Yeah.
But I'm curious. I mean, you mentioned earlier, that it's not like we have that many lava lakes on Earth, and there are a few like Kilauea and others. What is it that makes the lava lake at Erebus different? Is it that it has been sustained for so long, or what else?
It is that reason, but the main reason for that is the very specific and rare lava type that we look at in Erebus. So that is phonolite lava, and that is quite chemically advanced lava, you could say. Whereas in the other lava lakes, we have the very typical basalt lava, the most common lava type on Earth. So that is a very liquid, very fluid lava, whereas the phonolite is actually quite viscous. It's relatively thick. Yeah, so that is the main difference. So that is why it is also quite surprising that it wouldn't just cool down,
Yeah.
solidify, and
solidify,
clog the entire system.
And again, I was not particularly familiar with phonolite until I started trying to find out about it for this podcast.
Yeah.
Because I didn't have a clue about it. But it is very, very low in silica,
It is.
but very high in
Sodium and potassium.
Yes.
Alkali minerals. Yeah.
Now,
Interesting.
that was surprising to me because I've always associated the silica content with the viscosity.
Yeah.
Yeah.
But obviously there are other things at play, so it's
Yeah.
not quite that cut and dried. So this is actually very, very low silica lava, and yet still is quite viscous.
Yeah.
Yeah. Due to those other chemicals. Yeah. It's interesting because I would say like the probably more sort of simplified way of explaining it normally for lava flows on the surface of Earth. This is how we usually go about it here at Lava Show, where we talk about how like low silica, like basalt, which we would normally say is low silica under 50%, flows very easily and is, what we associate with the typical lava rivers that we have.
Yeah, exactly.
Yeah. Okay, interesting. I'm also interested in because when we were preparing for this, there's a few surprising elements when it comes to Erebus. There's a few sort of hidden secrets that lie beneath, and one of them has to do with gold.
Yes.
Tell us about that.
Yeah, so it happens that Erebus, because it constantly erupts, it emits tens of grams of gold into the air every day. Yeah, unfortunately, it is not a very feasible operation to go down there and collect the gold. You wouldn't want to do that because it is actually microscopically small. So you wouldn't be able to catch it. And it also has been found up to 1,000 kilometers away of that volcano.
It spreads out quite.
It does, yeah, because it is sort of just accompanied with the gases that come out. So this is why it spreads very far.
I would love to know how they figured this out.
They actually used air filters for that. So they put the volcanic gases through the air filters, and this is how they found it.
So where's this? Where's
It
the gold?
reminds me of old school,
Gold washing.
Yeah, panning for gold. Yeah.
Like air filters. Oh, there's a gold.
So where's it actually coming from? Is it just dissolved within that lava and just getting vaporized, or?
It is. So what is so interesting about Erebus is I already said that it's very chemically advanced lava. So that means there's a lot of processes that go on with the magma while it is underground. And this is also where the gold sort of vaporizes into the gases that come out. Yeah.
Erebus also is apparently quite well known for its volcanic bombs. Ding the bell.
Ding.
What is a volcanic bomb?
So what happens here is that we have gas bubbles that come through the surface, through the lava. And then, of course, when they come to the surface, that releases pressure. And then with that, there can be smaller or bigger chunks of lava that get shot out of the cone. In this case, they can fly a few 100 meters high. So
How big are we talking in these?
I believe they can be up to a few meters big, actually. They can be quite large. Yeah.
I visualize getting a big truck flying into the air and just boink.
Yeah. Yeah, I mean, we said it's quite regulated, but it's still a volcano, right?
Yeah,
So
yeah.
it's only as regulated as it gets.
Yeah, volcanoes, they are mischievous
They certainly are.
things, aren't
Yeah.
they? And full of surprises, apparently. I mean, this one sounds very unusual, this particular volcano.
It is.
gold, I mean, we talked about it a little bit earlier, but you were talking about how like evolved the lava is. Is there anything else in terms of the chemicals that you haven't mentioned yet, or have you completed that list of unusual things?
Almost, I think. I think one more interesting fact is that it also collects feldspar crystals inside the cone. So that is also pretty unusual. So that also comes from the phonolite lava because there's a high percentage of feldspar in it.
Yeah.
So that collects inside the volcanic cone as well. That's really cool.
Side question.
Phonolite, by the way, here's another little fun fact for you. The reason it's called phonolite is because it forms these kind of like sheets, and then if you kind of tap one of the sheets with a hammer, it kind of goes ding.
Oh, like our bell.
Like our bell. There we go. There you go.
Yeah, phonolite translates to sounding stone. This is where the name comes from.
Phonolite, yeah.
Yeah.
Do we know if this happens at any other volcanoes?
Interestingly enough, Erebus is very similar to Kilimanjaro and Mount Kenya as well. So what phonolite lava apparently does is it builds these huge mountains. So Erebus is almost 4,000 meters high. It's like at like 3,700 something meters. So it seems to really form these very typical stratovolcanic cones. Yeah.
So since I have not been to Antarctica, and I think most people have not been to Antarctica, given the fact that the volcano itself is so high, and you talked about it earlier that, you know, the ice cap is, like the ice itself on Antarctica can be up to 4 kilometers deep or like, thick.
Yeah.
Like, does the volcano stand out? Like, do you see the bedrock? Like, do you see the rock stand out? Is it covered with ice? How does it look? Could you describe it?
Yeah, so in this case, it actually does. So it is very close to the coast, and it is sort of just a neighbor of McMurdo Research Station and Scott Base, which is the New Zealand base. McMurdo is the US-American base. So they have Erebus in their backyard, which I'm a bit jealous about. But so yeah, you sort of are at sea level, and then just behind these research stations, this giant cone just rises into the air. And it really looks like the very typical volcanic cone that we know out of children's books, for instance.
Triangle shape.
Kids drawing of a volcano.
Yeah, exactly. Yeah. This is exactly what it looks like.
Okay.
Yeah.
So you would, like, anyone who would see it would be like, volcano.
Definitely. For sure. Yeah.
Okay.
So, I mean, we've talked about the ice. I mean, we know from our situation in Iceland that, you know, ice plus volcanoes isn't necessarily always a great thing.
Yeah.
It must make it, though, incredibly difficult to actually try and find evidence of previous eruptions. You talked about satellite stuff there as well. I mean, what other ways do they have of actually figuring out like what's going on underneath all of that stuff?
So I think the main method they would be using is radars. So they will put radar systems onto planes and sort of move over the areas that they're interested in. And then there's two other ones. One has a lot to do with gravity, because volcanic rock is more dense and with that heavier than the other sediment that is down there. Now, this is how they recognize the volcanic rock under the ice. And then also it has a lot of metals. So this is why they can use very sensitive magnetic systems to survey the ice like this.
Is it possible that any of these volcanoes could actually be actively erupting without us realizing that they are?
I think that would be unlikely, because that would certainly give us seismic activity if we have any eruptions. It would be possible that we get seismic activity and there is an eruption, but it wouldn't come to the surface because the volcano and the lava would not come through that thick sheet of ice. So it would melt some of the ice, sort of then have underwater, under ice eruption, you could say.
Yeah.
But we wouldn't necessarily see it. But I believe there would be signs that could be measured. Yeah.
Antarctica has very often been sort of the core of conversations when it comes to climate change and, you know, the rapid melting of the ice in the poles. I'm just curious. I mean, you know, there is obviously evidence that the ice is melting, but what about the ice melting from below due to volcanoes and geothermal heat, etc.? What do we know about that? Do we know if it's happening steadily? Do we know if this is a big contributor to the melting of the ice, etc.?
Yeah. So it is certainly a part of it, but it is a very small part of it. And that I want to make sure to really clarify here.
Do you know how small?
I don't know exactly, no. But it is a very small contribution, and the biggest problem for Antarctica is certainly the heating, the warming of the ocean,
Yes,
and the atmospherical warming as well. So, of course, there is a little bit of geothermal heat, and that will destabilize glaciers in West Antarctica under the rift or above the rift system, you could say. And that, of course, changes how glaciers move as well. So they can speed up, they become more unstable from that. But certainly the biggest threat for Antarctica is climate change, by far. Yeah.
How much is the ice melting? Like, do we have any kind of real indication of how much kind of regression of the ice actually is happening?
I can't give you exact numbers, but what I do know is that specifically the sea ice and the glacier ice that is near the ocean is sort of creeping under the ice, and it becomes way thinner than it's supposed to. And a real threat is actually that the ocean sort of moves under the glacier, and with that destabilizes it. So there is actually a glacier, another very dramatic name. The nickname is Doomsday Glacier.
Of course it is. What else would it be called?
It has an actual name, that's Thwaites Glacier. So that is sort of considered to be the cork of the West Antarctic glaciers. So the cork.
Cork, as in a bottle.
As in a
Cork.
bottle, yes, to make that make sense. So this is a massive glacier, and it's sort of losing its grip on the bedrock. So it is sliding towards the ocean, and if that glacier were to be released, that would increase the ocean levels worldwide by roughly 60 centimeters.
What?
Yes, just that one glacier. And the sort of fear is, so this is where the nickname Doomsday Glacier comes from, is that the other glaciers in West Antarctica would follow, because the theory is that the cork, so the Thwaites Glacier, is holding in the other glaciers.
Right.
So if that were to go, all the other ones could follow, and that means an increase in ocean levels of more than 3 meters on Earth. So that could significantly change Earth.
Hence the Doomsday Glacier.
Yes. Yeah. So Doomsday Glacier, of course, sounds like it could happen tomorrow. It is not going to happen tomorrow, so we don't have to be scared about that. But there's a lot of if and whens.
And this is partly, if I'm understanding this correctly, because the ocean is sort of creeping underneath.
Undercutting.
Correct.
And then like slowly sort of heating it up from below.
Exactly.
Thereby the glacier loses its grip on the bedrock.
Exactly.
Do you actually see the evidence when you go there that the ice is kind of shrinking away? I mean, or is it when you get there, there's just so much ice around that you just it doesn't really register that there might be any loss of it?
So we are in the middle of a glacier between 2 mountain ranges in the middle of the continent.
Yeah.
So
you're far inland.
Exactly. Yeah. So like in Iceland, for instance, if you go to Sólheimajökull, you can really, if you visit every month, you can see a difference every single month. Now that I've been here for 5 years, it's really shocking how much it has gone back.
Right.
Yes.
So I don't have an experience like that in Antarctica. What I can say is that sometimes you get weirdly high temperatures. So sometimes we did have like 0 degrees and sometimes even +2, and we were like, oh my god, what's happening? It's like heat wave. So,
to put this in context, what would you normally expect?
It depends a little bit. So the place where we are on Union Glacier is actually quite mild temperatures. So when we get there in November, that's still a bit colder. You could say like between -20 and -30 at the max. That would be really cold. And then throughout the season in December, we would
Which
usually...
is the summer.
Exactly. That's
Yeah,
that's like
it's,
high summer
Yeah.
bikini weather.
Yeah.
So,
2 degrees Celsius.
yeah. So that would usually give us like maybe -5 on like maybe very windy and cloudy days, maybe -10. But 2 degrees, that was quite shocking. Yeah.
And I mean, when you're there, also very dry air, I would assume. So it feels probably warmer than the actual number says.
Exactly. Yeah. It is very odd that Antarctica is the biggest desert with so much frozen water around you that it's still dry, but the snow there really behaves like sand. So you couldn't build a snowman because it doesn't stick together. Yeah.
But you said earlier something that sort of stuck out to me. You were basically saying that, because of the geothermal systems underneath the ice, but also because of the ocean, the ice is moving. And I think that, for some people, they think that an ice sheet is just like stationary, but it is definitely not.
It's not.
And I mean, I think that we who live close to glaciers or ice sheets of any kind of measure know this, but this is not necessarily common knowledge that the ice is always moving, also based on the seasons and all that. Like, is this like similar to the levels of it in Iceland, do you know, or is it like more significant due to the size of the ice sheet?
I think it just depends on the specific glacier we're talking about.
Okay.
I mean, in Antarctica, we have like this one massive ice sheet, but it's still separated into glaciers that are named as well. So then it just depends on the slope, because glaciers, of course, move under their own weight. And if there's a very steep slope, they will move faster. And if it's very shallow, it might just move a few meters per year or something. Yeah.
Okay. I just had to ask.
Yeah, no worries.
All right, so we are kind of coming towards an end of things, I think, here. But I guess the big question is, if Antarctica is so volcanic and it has the potential, as we were talking about there with, Deception Island, of some pretty horrendously large eruptions, should anybody care about Antarctica's volcanic activity, or is it just safe enough to just kind of keep it at arm's length and not think about it?
I think if people are not interested, it's safe to say there's nothing destructive going on in any kind of the future. There's no evidence for that. So if people are not interested in volcanoes, then they can just put that aside.
And then they're probably not listening to this podcast.
Exactly.
No, that's almost certainly true, yeah.
So if people are interested in volcanoes, I personally think this is a super interesting field. I mean, there are so many examples of really interesting volcanoes down there. And in general, Antarctica, for me, I mean, I'm very biased, but I think it's a wonderful place that has just been kept so pristine for research and for peaceful purposes. And I think it's such a beautiful place to learn from. It's very different to anything else we can see on Earth, not just the volcanoes, but everything else there.
That in itself is a parallel to what we were talking about in the last episode about Surtsey, which was preserved for science and now is basically its own little kind of closed off research centre.
Yeah.
And so the fact that, Antarctica, okay, yes, much bigger, but in many ways it's so difficult to get there that it is largely been kept pretty pristine as well.
Yeah, exactly.
But I think from a volcanic point of view, I mean, we've mentioned this in previous episodes, but where there's ice and volcanic activity, with the reduction of the ice, it's a known fact that volcanic activity increases. That's usually how it is. So if all the ice, now I'm just like hypothetically speaking, but if all the ice were to disappear, there would probably be more volcanic activity happening
that's definitely
in Antarctica and other places where the same is happening. So, I think Antarctica, for me at least, after having gone through what we've discussed here today, has become way more interesting. But that is, of course, because I'm such a huge volcano enthusiast.
Yeah.
So, you're going back there.
I am.
Yeah.
I am.
When's this happening?
I actually just signed my contract last night, so exciting.
And going back when?
Beginning of November. So the season is always from the beginning of November through December, January, and then we make our way out of there again. That's when it becomes too windy and too cold to be there.
Anything in particular you're looking forward to?
I think just everything almost. So the nice thing is we're like around 100 people that work there. You become like this little family, whether you want it or not. So it's kind of nice. We always, spread out all over the world for 9 months, but then we always make our migration down south again from all of the corners of the planet. And I think that's just so beautiful. And to I look forward to my tent again, actually, to just be in my cozy little space and, in front of the mountains, in the ice, wear my cozy gear. I think
your
really
love for
nice.
Antarctica and passion really does shine through.
It
That's
does.
obvious, yeah.
It does. You're kind of making me almost want to go.
Yeah.
Almost.
You should. Highly recommend. 10 out of 10.
Excellent. Oh, well. Thank you so much for coming in and chatting to us. That was super, super interesting.
Thank you for having me.
And all the best for your next adventure.
Thank you. Thank you.
So massive thanks to Ann-Sophie for joining us for the podcast this month. A complete surprise to me finding out all that stuff. I don't know about you, but
I mean, Antarctica for me was always sort of like this far away thing that I didn't think too much about.
Yeah.
So interesting what's going on there.
Yeah.
I mean, it's pretty clear that Ann-Sophie is in love with this place.
Yeah, totally. That really does come across.
Yeah, but apart from her fascination with it, I think that Antarctica has so much more to discover yet, and it's very interesting.
So, fascinating place, and we hope you found it fascinating too.
Absolutely.
And if you did find it fascinating and you want to tell us how fascinating you found it, you can always email us, podcast@lavashow.com. And if you want any other information, and actually there's a whole stack of stuff. If you go to lavashow.com and find the Lava Academy section there is a huge amount of information now.
Yes.
Not just the podcast.
No. Lots of articles, interesting facts about volcanoes, both in Iceland, but also on a broader scale. And we are trying to build up this realm of knowledge about volcanoes.
A bank of information,
knowledge.
if you like. Do check that out. Seriously, if you are interested in finding out more about, any kind of volcanoes, Antarctica or otherwise, have a look on there.
And if you know about anyone who you think might be interested in this kind of information, whether it's via the podcast or some articles, do share. Share it with other people, because that is essentially the purpose. We are trying to inform the world about the fascinating topics of volcanoes.
Yes, indeed. So yes, do the usual kind of sharey things if that is how you operate. So you can share, links to the video on YouTube or the podcast links. And you can also, if you're interested in finding out any more, yes, there's the website, but we've also got the social stuff.
We're on Instagram at Lava Show Iceland. We're on TikTok. We are on LinkedIn. Most of the social media platforms, actually. So.
And if you happen to be in Iceland, come in and see us.
Absolutely.
We'd love to meet anybody who's been listening. That'd be fun.
Yeah, for sure. And also, we've had a few comments and suggestions from some of our listeners. So if you have anything, as we mentioned before, you can always reach out to us and give us your thoughts.
Excellent. Anyway, I think that's about it for this episode. So thank you very much for joining us.
Thank you.
And we'll hopefully see you again next time. Bye for now.
Bye-bye.